Okay, well, dear followers, how are you? I'm glad to see you again, and stay safe. Today's topic is concerned about the infectious disease process. It is chapter 3 or unit 3. Just we have seen introduction to epidemiology and additionally theories of disease causation as chapter 1, and natural history of disease and prevention, types of prevention as chapter 2 or unit 2, and now infectious disease cycle or infectious disease process is considered as chapter 3 or unit 3. So please stay with us until this chapter ends. Okay, this is the lecture outline. This is learning objectives. Now we have started the topic. So our topic is infectious disease process or infectious disease cycle, or you can say infectious disease epidemiology. So an infection is an invasion or multiplication of microorganisms inside the host or one's organism, irrespective of whether that organism causes severe illness or disease. So an infection is once microorganism enter into one's body or host and invade and multiply. One's body is called infection, whether depend on it is causes disease or not, we can say infection. So as compared to infection and disease, when we see disease is an abnormal condition, an abnormal status of an organism which interrupts the normal bodily functions that often leads to feeling of pain and weakness, usually associated with symptoms and signs. So as we know, disease is an abnormal condition of one's human body. So due to that disease condition, normal bodily functions will be interrupted. So there is some feeling of pain, weakness. Mostly disease is associated with signs and symptoms. So this is known as disease. When we say infectious disease known as transmissible disease or communicable disease. So, or you can say infectious disease. So these are comprise clinically evident illness caused by biological agent. By the way, infectious disease means a disease which transmitted from one person to other person by contact or by any means of transmission, way of or mode of transmission. If a disease or biological agent or one causative agent transmit from one person to person, we can say communicable disease or infectious disease. So this communicable disease comprises clinically evident illness caused by biological agent. That means having severe illness or sign symptom. So infection implies that agent has achieved entry, began to develop or multiply, whether or not the process leads to disease. Yeah, as we have seen. So first, when we say infection, first the agent or the agent or the causative agent should enter to the host or the organism, then begin to develop or multiply in the host body, whether it's irrespective of the development of the disease. Is called infection. So infectious disease process of specific disease is traditionally described by the following components. So infectious disease process means chain of transmission or transmission cycle or chain of infection, we can say. So infectious disease process or chain of infection having six components. The first component is causative agent. The second one is reservoir. which holds causative agent. The third is portal of exit. How causative agent exits the reservoir. The fourth is mode of transmission, how the causative agent transmits from one person to the other, or from one host to the other. The other is portal of entry, how the microorganism or the causative agent enters into the susceptible host. So what is susceptible host is the last chain. This is how we say chain of infection, because this is circle, so one leads to the other. So let us see. So the major components of infectious disease process which constitute the chain of disease transmission is six. The agent or the causative agent, the reservoir of the causative agent, exits, mode of transmission, portal of entry, host or susceptible host. So this is chain. So causative agent, then reservoir, then portal of exit, then mode of transmission, then portal of entry, then susceptible host. So now this chapter mainly covers these six components. As these components, after observing these six components in detail, this chapter will be ended. So the first component is known as the agent or the causative agent. Causative agent includes viral particles to complex multicellular organisms, from the smallest particle, that is a virus, it reaches up to the complex multicellular organisms will be the causative agent. So the causative agent. So causative agent having intrinsic property as well as host parasite or infectious agent interaction, having two interactions. The first is intrinsic property of the causative agent. Many characteristics of infectious agents are agent determined or intrinsic to the agent itself, do not depend on any interaction with host. That means these intrinsic factors of the causative agent are morphology, the morphology of the agent, the size of the agent, the chemical characteristics of the agent, the genetic makeup of the agent or phenotype of the agent is an intrinsic property of the infectious agent or the causative agent. So the host parasite interaction or infectious agent interaction, many properties that are ascribed to infectious agent are not actually intrinsic to the agent, but are depend on the interaction between the agent and the host. So some are intrinsic to the agent, but some are also not actually intrinsic to the agent, but also the interaction between the infectious agent and the host, the susceptible host. So these interactions are included in this category, or host parasite or host agent interactions are: the first one is that infectivity or infectiousness. The second one is pathogenicity or pathogeneousness. The third one is that virulence, and the fourth one is that immunogenicity. So let us see in detail this. So when we see infectivity, it is the characteristics of the agent that embodies capabilities to enter, survive, multiply, or produce infection in the host. So it is the ability of the agent to produce an infection in the host is called infectivity. After one organism enter into the host body, it may not be produce an infection. So infectivity means the ability of an agent or the microorganism to enter in the host body and multiply or produce an infection in the host. So the ability to produce infection is called infectivity. The proportion of exposures that results infection. This means infectivity can be calculated that, or can be estimated that how how many of are result infection from those exposed individuals or those exposed individuals. So the number of infected individuals divided by among those who are exposed to that microorganism is called infectivity. So can be evaluated by techniques such as secondary attack rate, because secondary attack rate means is calculates the contact, how many infected individuals contact with index person. So the second type of category is pathogenicity. Pathogenicity is the ability to produce clinically apparent illness, the ability or after infection is developed, how the microorganism is produce clinically apparent illness. So there is exposure here, so there is infectivity here, infection here, and here there is infectivity, there is disease here. So there is days or severe illness here. So from exposure to infection is known as infectivity. From infection to disease, clinically apparent disease, is called pathogenicity. From the disease to severe illness or death is called virulence. This is virulence. This is pathogenicity. And this is infectivity. So the ability to produce clinically apparent illness is called pathogenicity. Pathogenicity is the proportion of infections resulting in clinically apparent illness. This means pathogenicity is estimated from the number of clinical illness among those who infected. This means the number of individuals who develop clinical illness divided by those of infected. So how many of are develop illness from those of infected, among those of infected, is pathogenicity. So the third one is that virulence. Virulence is the proportion of clinical cases resulting in severe clinical manifestation. By the way, severe clinical manifestation means either severe illness or death. This means that virulence is estimated that among the number of individuals who develop severe clinical manifestation or death, or the number of individuals who died divided by the number of who develop clinical case or disease. So the number of disease, the number of days or the number of diseases divided by the number of diseases is called virulence. So this is case fatality rate. Case fatality is one way of measuring virulence. This is also the same. Case fatality rate means days over the number of days divided by the number of individuals who develop disease. How many of they develop illness, how many of they are died among those developing disease, indicated to be virulence. So many depend on dose, meaning the virulence can be determined by dose, depend on dose, route of infection, and host factor such as age, race is also contributing factor. And the last one is that the fourth one is that immunogenicity. Immunogenicity is the ability of an infection to produce specific immunity. That means some individuals, some microorganisms or infectious agent, after infected one individual, they will develop specific immunity. That means once this disease affects the individual, since they develop immunity, reinfection is impossible. That means there is no reinfection or infection for long period of time or permanent, like poliomyelitis, influenza will produce immunity. So this is also another characteristic. It may lead to protection against reinfection or reactivation with the same or similar pathogen in the future. Once that microorganism infected an organism, and once it leaves after developing specific immunity, reinfection or reactivation of that similar pathogen is impossible for the future. Some are for permanent, some are for long period of time. Immunogenicity can be affected by host factor such as age, nutrition, dose, and virulence of infection will affect the immunogenicity. So to observe in detail, infectivity means the ability of microorganism to infect an individual. So can be calculated. Infectivity is equal to the number of infected individuals divided by the number of susceptible or exposed individuals times 100. To calculate pathogenicity means the ability to cause disease. The ability to cause clinically evident illness or disease. So pathogenicity is equal to the number of individuals with clinical disease. The number of individuals with clinical means disease having sign symptom. So the number with clinical disease divided by the number of infected individuals. The number of infected individuals times 100. So among those infected, how many of are develop clinical disease? Among those who are susceptible or exposed, how many of are infected? So the other is virulence, the ability to cause death, either severe illness or death. The ability to cause death. So how many of individuals those with disease develop disease, or how many of those with disease died. So virulence means is equal to the number of individuals died divided by the number of individuals with disease. So the same thing, case fatality is equal to case fatality rate is equal to the number of deaths of individuals divided by among those with disease times 100. So all these factors are depend on the host factor. So the first component of infectious disease process. The first component of infectious disease process is infectious agent, but the second one is a reservoir. The reservoir of an agent is an habitat in which an infectious agent normally lives, grows, multiplies. So reservoir means a habitat or a place, a favorable place in which an infectious agent normally lives, grows, multiplies, and causes infection. A reservoir of infection include reservoirs may be human beings, vertebrate animals, invertebrate animals like arthropods and mollusks. And arthropods means like insects and ants. The other is environmental sources. Environmental sources are like plant, soil, and water. All these are considered to be a reservoir. Many infectious diseases have more than one reservoir. So identifying the number of reservoirs is one of important things, because as the number of reservoirs increases, disease prevention and control will be difficult. Because it should be the number of reservoirs should be identified. So as the number of reservoirs increases, easily control and prevention of the disease will be decreases. will be decreased. So the agent or the infectious agent with human reservoir, meaning agents who have that have human reservoir is like measles, mumps, typhoid, gonorrhea. Most respiratory pathogens like pertussis are having human reservoir. In general rule, the greater the number of different reservoirs for a given disease, the greater the difficulty of controlling the disease. Example, malaria. Types of reservoirs. The first reservoir is man or human. Man or human is measles, smallpox, typhoid, meningitis, gonorrhea, syphilis. And the cycle of transmission is from man to man. The cycle of transmission is it's transmittable from one person to the other person. The other is animals. Animals as a reservoir. That is causes zoonotic disease. So bovine TB, cow tumor. It's transmitted from the cows, from humans. Brucellosis, it will be transmittable from cows, pigs, goats to human. Like anthrax, the reservoir is cattle, sheep, goat, horses. And rabies, dogs. The main reservoir for rabies is dogs, then fox, other wild animals. It will be also transmittable to human. So the other is non-living things. Non-living things will be also act as a reservoir, like saprophytes living in soil, like Clostridium tetani, Clostridium botulinum, Clostridium tetani is an example. So this is reservoirs. Human reservoirs may be persons with symptomatic illness or carriers. By the way, when the human being contains an infectious agent, or a human being is acts as a reservoir, either the reservoir or human being act as symptomatic or asymptomatic. So symptomatic means after invading by infectious agent, they will develop symptomatic illness, and also they will develop they will be also carriers. Carriers means there is infectious agent but there is no sign symptom. So let us see in detail about carriers, because it is important epidemiologically. So carrier is an infected person without manifestation of a disease. An infected person, that carrier means a person or a reservoir contains microorganism or infectious agent, but still there is no showing manifestation of the disease, or there still he or she has not showing signs and symptoms of the disease. But still they capable, or they have the ability to transmit an infection to the others. So the main characters of carrier is it is an infected person. That is not showing the same symptoms of the disease, but still he can transmit or she can transmit the infection to the other persons. So this is known as carrier. The importance of carriers in the transmissions of disease depend on their number. That means the role of carriers, the importance of carriers in transmission depend on number. So the number also one factor. Low number, high number is the factor. The other is non-detectability. Maybe the microorganism or the infectious agent it is non-detectable. So some are detectable, some are non-detectable. This is also factor. The other is mobility. and also the other is chronicity. These four are important factors that affects the transmission of disease in carriers. So we have four types of carriers. The first carrier is known as asymptomatic carrier. The second one is incubation carrier. The third one is convalescent carrier, and the fourth is chronic carrier. So when we see asymptomatic carrier transmit the infection, these carriers have ability to transmit the infection without overshowing the manifestation, or the sign and symptoms of the disease. An example is poliomyelitis. It is about 95% is asymptomatic. Amoeboisis and HIV/AIDS. So there is no sign symptom, but they can transmit the infection. The second one is that incubatory carrier or incubation carrier. So these carriers have the ability to transmit the infection by shedding the agent before the onset of clinical manifestations. So this type of carriers also transmit infection by shedding the agent before the onset of sign symptoms. So these types of diseases are measles, 1 up to 3 days. Mumps, 5 up to 7 days. Viral hepatitis B, AIDS, rabies in dogs and cats are an example for incubatory carrier. The third one is that convalescent carrier. These carriers have the ability to transmit the infection after the time of recovery from the disease. So this type of carriers they have the ability to transmit an infection after they have recovered from the disease. So an example is typhoid fever. Is an example. So the last one is chronic carrier. These carriers have the ability to transmit the disease for long period of time, or we can say indefinite period of time. They can transmit the disease for long period of time. These types are viral hepatitis B, maybe permanently. Typhoid fever. 2 up to 5% of typhoid fever, they will transmit permanently. So these types are chronic carrier. They will transmit the infection for long period of time. Now, carriers are the challenges of public health professional, because they spread more disease than the clinically apparent ones. Because by the way, one of the challenges of in carriers is that they will transmit more disease, more infection from one person to the other, as compared to individuals who have the disease or clinically apparent disease. Because the disease are apparent because they show signs and symptoms, so they or their relatives or those who have contact with these persons will be cared, because it is observable, so it is easy to prevent and control. But in the case of carriers, they will transmit, but we cannot know whether they have the disease or not. So it will be an epidemic. They will raise an epidemic. So it is very challenging public health professional to prevent and control, or to limit the transmission. So an example is this one: iceberg or hippopotamus effect of carriers is like this. For instance, this is for now for this is clinically apparent illness, this is carriers. So when compared to the disease cases or disease with carriers, so this is ocean, for instance, or NEC. So this is boundary. So we have observed only this one now in cases, but this the hidden one is carriers that we cannot be easily seen, or it cannot be easily observed. Okay, this one. The same thing is for hippo. So now we can easily see above this one, but the total bodies cannot be observed because it's below the sea. So the one which is not observed is carriers, the one which is observed is cases. So cases are very small in number as compared to carriers. That is the case. It will be public health concern. Okay, carriers are public health concern. So the time course of an infectious agent, when we see the time course of an infectious agent, we do have 4 time courses. The first one is a pre-patent period, the second one is incubation period, the third one is communicable period, the fourth one is latent period. So when we see these 4 periods, this is a time course of infectious agent. When we see the pre-patent period, a time interval between infections or biological onset and a point at which infectious agent starts to shed. So a time between infection or biological onset and an organism starts to shed is called pre-patent period. We can say pre-patent period. This period is sometimes known as window period, as diseases like HIV/AIDS. This period can be considered as window period, the window period. Okay, the window period. So this is a period between infection or biological onset and shedding period. So the second type of period is an incubation period. An incubation period is a time interval or period between an infection, biological onset, and the first clinical manifestation of the disease. So a time between biological onset, a time between infection and the development of clinical manifestation of disease, or the time between an infection and the development of signs symptoms of the disease is called incubation period. Or in another meaning, we can say that incubation period is a period between biological onset and clinical onset. We can say that a period between biological onset and clinical onset is considered as incubation period. The third one is that communicable period. We can say infectious disease period. It is transmittable period. So this is a period during which an infected host can transmit an infections to the others. So this period is communicable period or transmittable period. So the host can transmit an infection from one person to the other. This period is communicable period. This is a period between the two shedding areas. An agent can start shedding and an start can stop shedding. So start shedding means starts to transmit, stop shedding means stops to transmit. So the period between two, starting an microorganism start to shed and end to shed, is called communicable period. The fourth one is that latent period. Latent period is the time interval between recovery and the occurrence of clinical disease or the occurrence of disease, or you can say the recovery time, between the recovery time and relapse of the disease. Relapse of the disease means after one disease is recovered, it will be relapse again. So the time interval between recovery and relapse of that disease is called latent period. So an example of the disease that have latent period is typhus and malaria relapsing fever. There is malaria also, it will be relapse. Typhus and malaria will be relapsed or have latent period. Okay, so these four are the time course of an infectious agent. Let us see the diagram. It's very this diagram is very important diagram, which shows the time course of the disease in relation to its clinical expression. So let us see first this line. This line is a place which is above this line is known as symptomatic. This one is asymptomatic. So cases which is symptomatic is known as clinical cases. But cases, an individual or an infected person who is asymptomatic is known as carriers. So carriers, we have incubatory carrier, asymptomatic carrier, and chronic carrier. This is carriers. So this is carriers. So this is carriers. This is cases. So the other is time course, time of infection. When we stay, so at this place, and time for a person is infected. So this is time of infection. After some time, agent starts shedding. Then after some time, there will be clinical onset. Here. After some time, recovery will be here. A person will be recovered. The other is a person after recovery. There is agent, an infectious agent will stop shedding. Then it will, maybe they will relapse. So this is time. So a time period between the time of infection and agent starts shedding is called pre-patent period. So a time period between an infection and this clinical onset or the starting of sign symptoms is called incubation period. So a time between recovery and relapse means recur again, is known as latent period. Between relapse and recovery is known as latent period. So time period between the agent start shedding and the agent stop shedding, so this time is known as communicable period. So an individual who is in time period between these two periods start shedding and stop shedding is called communicable period. So this is all about an infectious disease time course. Okay, time course. This diagram shows carriers, cases. It is time course of a disease. It will shows. So the other is portal of exit. The third type of component is portal of exit. Portal of exit is the way the infectious agent leaves the reservoir. How the infectious agent leaves the reservoir. So the possible portal exit include all body secretions and discharges. So all this is our substance. So all body secretions and discharges like mucus, saliva, tear, breast milk, vaginal, cervical pus, urethral secretion, semen, pus. So exudates from wound. All these are the cause of infection after exiting a reservoir. So the second type is excretions. like feces and urine. The third is blood. The other is tissues including placenta are considered to be substances which causes infection after exiting from the reservoir. So this is breakage of the skin. So this is for instance blood. This is a portal of exit. Nose, secretions, the portal of exit. Teres, ear, earwax. Mouth, saliva and septum. And vagina in female, like vagina, milk or something like that, secretions or blood. Semen and urethra, urine. Anus, feces. This all are the portal of exit, and also will be also the portal of entry. The other is mode of, the fourth one is mode of transmission. Mode of transmission is the mechanism or the modes by which the agent escapes from the reservoir host and enter a susceptible host is called mode of transmission. A mechanism or a mode by which the agent escapes from the reservoir host enter the susceptible host is known as mode of transmission or the mechanism of transmission. So how the agent or the infectious agent leaves the reservoir host and enters susceptible host. This process showed by the mode of transmission. There are two major modes of transmission. The first one is that direct transmission. The second one is that indirect transmission. So direct transmission have also direct contact, direct propagation, and others also. For instance, direct contact and direct projection, transplacental blood transfusion and organ transmission are under the direct transmission. So direct transmission is an immediate transmission of the agent from reservoir to the susceptible host, either by direct contact or droplet spread. This means an immediate means there is no time cap, an immediate. For instance, when two persons are standing and communicating to each other, maybe they will lose their droplet spread through the saliva from one person's mouth to the other mouth directly, or maybe by direct contact, by handshaking, touching, something like that. So this is an immediate transmission. So for instance, the first example is direct contact for direct transmission. So direct contact is a contact of the skin to skin contact, and mucosa, conjunctiva with infectious agent directly transferred from another person or vertebral animal. So it will be transmitted from person to person by skin contact, mucosa or something like that. Same time, an infectious agent transmits from one person to the other person via touching. For instance, touching means a hand means after contact, after touching our diseased A, they will greet or they will hand another person hand. So eye, hand, eye in trachoma, face, hand, mouth in shigalosis, and nose, hand, A in common cold. And other is kissing, mononucleosis. The other is biting, like rabies. Sexual intercourse, like HIV/AIDS and STD. These are under direct contact. So this is known as also direct transmission. The other is direct projection. Direct projection is a projection of saliva droplets by coughing, sneezing, singing, or spitting, or talking. So when we are sneezing or singing or talking, the saliva droplets will fly or will droplet from the talking person to the other receiver will be transmitted. This is known as projection. So this is direct projection, also the part of direct transmission. For instance, common cold. If you talk, the person who has common cold, you will receive common cold because of the direct projection. The other is transplacental. Transplacental is a process in which transmission of microorganism from the mother to the fetus through the placenta. This is transplacenta. So diseases which is transmitted from mother to fetus during pregnancies like syphilis, toxoplasmosis, rubella. The other is blood transfusion, is direct contact. Organ transplantation is they will include it from the direct transmission. So these 5 categories will be categorized into direct transmission. The other is indirect transmission. Indirect transmission is an infectious agent is carried from the reservoir to the susceptible host by suspended air particle or by inanimate. That means suspended air particle. That means an infectious organism will suspended in the air for a long period of time, then will be transmitted. Then by an animate object. An animate object means like vector, mosquito, and fleas, ticks. This animate object means who have living thing. The other is by an inanimate vehicles. Inanimate vehicles means which is non-living thing, non-living substance like food, water, biological product, fomites are considered as inanimate vehicles. Like intermediaries also will be considered. So in this way, agents transmitted from or carried from reservoir to the susceptible host by this means is called indirect transmission. Let us see an examples. The first one is vehicle-borne transmission. The second is vector-borne transmission. The third is airborne transmission and non-vector intermediate hosts. The vehicle-borne transmission is a transmission, an infectious agent transmitted through any non-living substance or object like food, water, biological product like blood, and fomites. Fomites means material like handkerchiefs or hand towel. That means that will transmit microorganisms. This is fomites are like towels and so towels or clothes are considered as fomites. So this non-living thing is considered as microorganisms transmit through these parts or these things or substances are called vehicle-borne transmission. Mostly non-living things. The second one is that vector-borne transmission. This is a living organism. So it is the transmission of infectious agent by the vector. Vector is an arthropod such as insect, tick, mite is considered as vector. So vector can be divided into two: biological vector and mechanical vector. So malaria, for instance, mosquito in malaria is biological vector, salivary transmission, and also common fly in trachoma is considered as mechanical vector. This means common fly is an example of mechanical vector, mosquito is an example of biological vector. We have seen two. The third is airborne transmission. It is a transmission of infectious agent by either suspended dust or droplet nuclei suspended in air for relatively long period of time. It's not immediate. It is not direct. So either by suspended dust or droplet nuclei suspended in air for relatively long period of time is called airborne transmission. An example is measles. For instance, let us say, for instance, in clinic, if after one child is waited in clinic and treated or see a doctor by for measles, and after leaves they will enter another child which is free of measles, so he has the ability to capture or to get the measles infection or disease, because the measles have ability to stay in the air for long period of time. So since after leaving the first child which is infected by measles, the viruses will suspend in the air, and so the next child which is free of measles have the ability to get it. So measles is an example for airborne transmission. The other is non-vector intermediate host. These are hosts which are important for the development of infectious agent but do not play an active role in transporting the agent to the susceptible human host. An example is aquatic snail for schistosomiasis. Often diseases have several modes of transmission. Hence, it is often necessary to distinguish between predominant modes of transmission and those which are secondary importance. So, by the way, diseases which have or micro infectious agents who have several modes of transmission, it's very difficult to control because of several modes of transmission. So and understanding different modes of transmission is very important to control and prevent the disease. And also it's very important, the predominant mode of transmission is also very important. So these 4 types of transmission is considered as indirect transmission. Indirect transmission and direct transmission is a major groups of mode of transmission. So the 5th type of component is portal of entry. It is a site where infectious agent enters susceptible host. So the site an infectious agent enters susceptible host. So whether an agent will establish an infection depend on the suitable portal of entry. So unless an individual is an infectious agent is entered through suitable portal of entry, it may not arise, or it may not cause an infection. So suitable portal of entry is very important. So some of structures which have seen an exit of infection or an exit portal of a portal of entry is considered as, and a portal of exit is considered as for portal of entry. For portal of entry, for instance, anus is it is used as portal of entry or exit. So an example required portal the required portal of entry for agent of tetanus is to cause the disease, the site of injury. By the way, Clostridium tetanus, if you eat Clostridium tetanus, it may be not cause. So if you entered through mouth, it may not cause infection. Maybe it is an flora, so that normal flora, so that it may not cause an infection. But Clostridium tetanus is entered through the site of injury or breakage in the skin, it will cause the disease. So portal of entry is very important to determine whether an infection causes the disease or not. The 6th and the last one is the susceptible host. Susceptible human host is the final link in the infectious process. So this is the chain of infection. So the last chain of link is susceptible host. A person lacking sufficient resistance to particular pathogen agent to prevent the disease if exposed. So for instance, lacking resistance or immune deficiency is one of example of susceptible host. It will make it an individual susceptible for those microorganisms. So host susceptibility can be determined, can be seen at the individual level or at the community level. So our immunity at individual level, at community level also important, and also it differs. So at individual level, the state the host at any given time is the interactions of the genetic endowment with environment over the entire lifespan. So has the genetic makeup of an individual with environment or interaction with environment have very important. So we will have genetic factors and environmental factor as individual. So genetic factors like sex, being male and female, blood type, being A or D, ethnicity, being one ethnicity from the other is one of the genetic factors which will be holded by an individual. The other is environmental factor. Immunity acquired as a result of the past infection is an environmental factor. For instance, once in some diseases, if once an infection is raised, the microorganisms leaves it is immunity, specific immunity, so that reinfection is impossible. So this is environmental factor. At the community level, host resistance at the community or population level is called herd immunity. So the ability of the community or the resistance of the community to the disease because of the development of immune is called herd immunity. Herd immunity can be defined as the resistance of community to invasion and spread of infectious agent based on the immunity of high proportion of individuals in the community. High proportion of individuals in the community. So high proportion of immunes prevents transmission by highly decreasing the probability of contact between reservoir and susceptible host. So for instance, if you take coronavirus as an example, if almost all individuals, almost the number of individuals, or the proportion of individuals develop immune for coronavirus is increased. So even if some individuals will be left to develop immune, the transmission will be decreased because of the contact between immune and non-immune will be decreased because most of our have immunity. So that in this case it's very important. So when we say also coronavirus disease, some countries are already immune or take the vaccine. Some countries are not fully vaccinated, so that in non-vaccinated individuals the community is, we can say, less proportion, so that herd immunity is impossible. So even if 100% take vaccine or immune is not important, the number of immune individuals or the proportion of immune individual increases is very important. Its approach to 100% is very important. But in this case 100% immune is as such it is good, but it is as such 100% immune is not 100% recommended. This means because as the number of immune individuals increases, contact will be decreased, so the transmission will be decreases. They will kept by the majority of immune individuals. So the majority of population resist to one's disease because of immunity is called herd immunity. So conditions under herd immunity based operates are single reservoir, direct transmission, total immunity, no shedding agents by immune host, no carrier state, for example, uniform distribution of immunities, no overcrowding. All these are factors. The other is spread of disease through person to person. A person-to-person transmission of an infectious agent is one of the main methods of disease spread in the community, and it depends on generation time and herd immunity. Generation time refers to the period between exposure, infection, and the maximum communicability of the exposed host, regardless whether the disease is apparent or unapparent. So the time between an infection and maximum communicability, maximum transmissibility is called generation time. In case of apparent infections, generation time may be equivalent to incubation period. So herd immunity is the second one. Herd immunity is we have seen now. So the third one is secondary attack rate. It is a measure of the frequency of new cases of the disease among contacts with known cases. How many new cases are created among those who contacted with known cases. So this is an important measure of spread of disease among contacts of index case. It has great use in epidemic situations. So secondary attack rate is calculated by new case among contacts of index case during the period divided by the total number of contacts with index case. So new cases among contacts of index case divided by the total number of contacts with index case. So how many cases are developed disease or became new cases among individuals who have contact with the index case. Okay, the index case. So index cases are excluded from both numerator and denominator. A case that brings household any other group to the attention of public health personnel is known as index case. Meaning an individual, the first individual who catches the disease and will introduce into the household or into the community or into one's countries is known as index case. So the last section is principles of communicable disease control. Communicable disease control is a reduction of incidence or prevalence of communicable disease to a level where it cannot be a major public health problem. So minimizing an incidence or prevalence of a disease to the lowest, as much as possible to the lowest level is called communicable disease control. There are three broad areas of prevention and control. The first area is known as attacking the source of infection or reservoir. The second one is that interrupting the chain of transmission. And finally, the third one is reducing host susceptibility. These three things are, or these three broad areas are the main area for prevention and control of infectious disease. So the first one is that attacking the source of infection, that is to reduce the number of infective organisms. This means attacking the source of infection means if you attack, the number of infective organisms will be decreased. This is done by the treatment of cases and carriers. We should treat the cases and the carriers through mass treatment as in typhoid fever, schistosomiasis and tuberculosis. The second one is that isolation means it's a separation of an infected individual for a period of communicability. So isolation is recommended when the disease have high mortality and morbidity. The disease is killer, high fatal. If it is high fatal rate, high case fatality rate, isolation will be recommended. So until the period of communicability passes, it will be that person will be isolated. The other is have high infectivity. The infectivity rate and the virulence rate is very high. Isolation is recommended. Too. The third one is quarantine. Quarantine is a limitation of movement of a person or an animal who has been exposed to infectious disease for a maximum of incubation period for the disease. So the limitation of the movement of a person or an animal who has been exposed to infectious disease for a maximum of incubation period for the disease. So this is a limitation. So by the way, when the coronavirus arises, in some countries limit if that individual is supposed to be exposed to infectious disease, they will limit. For instance, some individuals will enter from the foreign to some country, they will restrict in some places for a maximum of incubation period for 2 weeks or something like that. They will be restricted to see whether they are infected or not. So this is quarantine. Related to this movement is quarantine. So the other is reservoir. So in corona, quarantine and isolation is was done in different countries. The other is reservoir control by mass vaccination to cattle and sheep, and killing, burning infected animals, rabies and anthrax. Killing and burning infected animals like reservoirs and anticals, cattle, sheep by mass vaccination to cattle and sheep, we can control the reservoir. So, for instance, if there is infected dogs by rabies, either kill, burn that animal. So since for rabies is reservoir is the dog, so if the dog is killed, so it will be controlled. Okay. The other is active surveillance of contacts. Effective reporting system is very important in attacking the source of infection and controlling the communicable disease. The other is interrupting the chain of transmission, mode of transmission. It is a control of mode of transmission from reservoir to the new host. So it is interrupting the mode of transmission from transmitting from the reservoir to the new host, to the susceptible host. So the first mechanism is environmental sanitation. For instance, intestinal parasite control. The second one is that personal hygiene, like Trachoma scabies control. The third is vector control, like mosquito, snail control. Malaria and schistosomiasis is a vector control. The last is disinfection and sterilization, purification of potable water, pasteurization of milk, disinfection of air is considered as the factors or the mechanisms which interrupting the chain of transmission. So these 4 things are supposed to be interrupt the chain of transmission. So they are important in control communicable disease. The last one is reducing host susceptibility. For instance, host susceptibility is reduced by immunization. So immunization is it's important for individual and herd immunity. So at community level, it's herd immunity. The other is better and improved nutrition. It's very important to decrease host susceptibility and to boost host immunity. The other is health education is very important according to the disease factor. The other is chemoprophylaxis for malaria, meningitis, tuberculosis, and person protection, like for malaria, use mosquito nets, clothing, repellents, and shoes for different types of disease. So these 5 categories are important to reduce the host susceptibility. So host susceptibility and reducing host susceptibility, interrupting the mode of transmission, and also attacking the reservoir of an infection or infectious agent is one of the main strategies of controlling infectious disease. This is all about the infectious disease process or infectious disease cycle or infectious disease epidemiology. So thank you very much for your attention. Thank you very much for watching this video. to get the next, this is chapter 3, so unit 3, so to get the next chapters of epidemiology, don't forget to subscribe this channel. And also to get the other type of courses, like different types of courses, so don't you have to subscribe this channel. And if you have comments, you can give us, and based on comments we will prepare different courses and health tips by expert health professionals and academicians. So thank you very much for your attention. Have a nice time.